Hello, everyone. My name is Maxwell Sivers-Boyce,
And I'm Ori Friesen.
and our project is on is there variation in night sky visibility at a neighborhood scale within an urban setting? And we were able to do this with assistance from Mr. Joe Minato and a lot of help from Mr. Michael McKeague. So a big thanks to both of them. So what our project is really about is we set out to measure the difference in night sky visibility at two locations in Southwest Portland. Those locations were Wilson High School and Gabriel Park, which are just about 2 miles away from each other. And we did this using SQMs, also called sky quality meters. They're these little rectangular boxes with a lens on one end. You can see them on the side there. You put that lens, or you put that box in a weather cover, and you stick it up straight at the zenith of the sky. And then it takes in the brightness of light pollution, and it measures that. It measures it in magnitudes per arc second squared, sorry. And you can see that in the diagram we have at the bottom there. So magnitudes are the brightness, are what we use to measure the brightness of stars. And so a magnitude per arc second squared is just that brightness diffused over an arc second squared, which is a unit of area we use when talking about the night sky. And we also use DSLR cameras in our measurements. Those are just kind of what you think of as like a digital camera, and we use those to take some pictures to get some qualitative data. And this project was all it was like a preliminary study for a greater project. We were thinking of maybe developing some kind of public observatory and we wanted to decide which site would be better for it, and also just for the star parties that Mr. Minato sometimes holds.
So now we're going to go into a little more background of our project. So the kind of background of it was that with star parties from the Wilson Astronomy Club, people have noticed that it was a lot easier to see the night sky at Gabriel Park compared to Wilson High School, and there wasn't any like substantial evidence about this, just anecdotal observations. So we kind of wanted to build off of this and create a better project of kind of seeing what the actual changes were. And a few of our guiding questions were, is this due to differences in surrounding light pollution? So there are kind of two kinds of light pollution. One is local light fixtures, and you can see those with just street lights in general. And there's also more, and that's very localized. And there's another form of light pollution, which is just light domes in general. And this is where the light from this whole city kind of covers and obscures the sky. So we wanted to see if there's actually a difference between like inside a specific light dome because caused by the differences in light fixtures in areas. And we wanted to also see if there were any differences in zenith sky brightness on a neighborhood scale. So I was kind of explaining with the local light fixtures, not necessarily just within just because of the sky dome, but anything inside that light dome. And at our procedure in each site, the first, we gathered both qualitative and quantitative data. The first step for this would be to gather zenith sky brightness data with the SQM. So we'd use these sky quality meters to kind of prop them up in what you can see in the picture to the right. That's at my house. And you just put that on a stake in the ground and point it at the sky. And this measures the zenith sky brightness every 5 minutes throughout the night. And later you'll be able to see the data that it gathers. And for qualitative data, what we wanted to do was set up a DSLR camera with an intervalometer, which is a device that allows you to kind of have a given amount, like an interval for when it takes a picture. So what we did was that we wanted to have the intervalometer set at 5 minutes. So we would take a picture every 5 minutes to correspond with the SQM data. So we can kind of see what the night sky actually looked like at these specific sites. And so that's the mixture of our qualitative and quantitative data for the specific night. Another thing we wanted to do at each site was more of a site survey. And what we did here is we took panoramas, the 360-degree panoramas of the surrounding areas where the lights were, where the SQMs were. And we wanted to get photos of significant features of interest in these areas. And we'll cover the panoramas later in the presentation.
So this is an example of what our data would look like from any given night. So on the bottom axis there, the x-axis, we have the times. This graph was from the evening of July 29th to the morning of July 30th. And each of those intervals on the x-axis, those are about 20 minutes each. And then on the y-axis there, we have the magnitudes per arc second squared. And magnitudes are measured inversely with the brightness of the star. So the lower the number, the brighter the star. So as we go down here, each of those intervals is about 0.5 of a magnitude per arc second squared, a little bit under that. So as we go lower, the numbers are getting higher and the night sky is getting darker. And so here are a couple of examples as well of what we are using the cameras for. So as you can see, this data is really spiky, and the pictures kind of provide some context because we can see that that night was pretty cloudy. And you might think that on a cloudy night, it would make the dark sky or the night sky darker. But because we live in the Portland light dome where there is so much light pollution, the clouds will actually trap and reflect that light, making the night sky a little brighter.
And here's an example of the panorama comparison that we saw. So there's Gabriel Park and Wilson High School, and you can see with Gabriel Park, the 360 panorama only provides like two significant light sources compared to Wilson High School, where there are dozens of lights you can see in this picture. And this provides some of that anecdotal evidence of provides evidence for those anecdotal observations of why it's better to see the night sky at Gabriel Park compared to Wilson High School. And even in these pictures, you can kind of see the light pollution from like more urban places with like cities and stuff. You can kind of see the lights in the background. And this just kind of proves how much darker it is at Gabriel Park and how there's so much light pollution at Wilson High School. And here's the actual data we gathered to, we made it more visible with both Wilson High School and Gabriel Park. And here, we have the same time on the x-axis here for the night of July 26th and 27th. And here's the same magnitudes per square arc second. And each interval is 0.2 magnitudes per square arc second. And you can see how Wilson High School, there's an observable difference in the light pollution, and Gabriel Park is a lot darker than it is at Wilson High School. And the difference here is 0.2 magnitudes per square arc second, which means that there is an observable difference from the different locations that we see in the same light dome. So it's kind of shows how significant our data is in this project.
Yeah, so our conclusions from this project, as Ori was talking about, is the zenith sky brightness at Wilson was measurably brighter than at Gabriel Park, even though they're in the same light dome and they're only a couple of miles apart. There was a noticeable difference in the zenith sky brightness. As the panoramas showed as well, there are much less potential sources of glare at Gabriel Park, just making it easier to be in a place where your night sky vision isn't going to be as affected. So both of these factors are consistent with having better visibility of the night sky at Gabriel Park. So in terms of building some kind of public observatory between the two locations, Gabriel Park would be the better location for the observatory, or just for star parties that we're holding.
And what's next with our presentation? So what I want to do, and I've been working with Minato for an independent research study, and the plan is to explore more thoroughly, explore the variation of night sky more thoroughly, because this was just a preliminary study, and we want to kind of use more measurements, figure out more locations, and design a better procedure to measure the differences and measure all the variables to our study. And one way we could do this would be to use lux meters to measure light sources, and this would actually be measure the brightness of the specific light sources instead of just taking pictures that we saw. We want to have a measurable, actually measure something from those light sources. Another possibility would be to use more SQM to gather more zenith sky brightness data. So instead of just using data from Wilson High School and Gabriel Park, we would want to do it at multiple locations throughout Southwest Portland, so we can figure out what the difference is and how different it is between these different places. And another option would be to use the Loss of Night app, which is an app that allows citizens to do their own research and provide data for professionals. And this is kind of going into citizen science, where people can actually make a difference in science without being professionals in this topic. So what it does, the Loss of Night app, is an app you can find on any on Android and iOS App Store. And what it does is it kind of walks you through the sky to kind of help you measure more qualitative data of sky brightness in different areas and kind of help measure that light pollution. So that's definitely another possibility that we can implement with Astronomy Club to allow our people, our members, to use that like on a given night. And currently I'm in the process of making a second procedure, and we'll definitely be needing help from other people who are interested from Astronomy Club. And I think since this was a preliminary study, we want to have a better procedure and a better experiment. And another option where future members could help out with this project is to go to Pine Mountain Observatory in that camp with Michael McKeague, because he's definitely interested in furthering this research. And that's definitely a perfect opportunity for people who want to go into dark sky and kind of help this research out. And another idea would be to, like with this project, would be to determine the most suitable location for a public observatory in Southwest Portland. And we've already kind of gotten the attention of city planners, and like we could work with the school district once Wilson is planning its remodeling to kind of help limit the light pollution at Wilson, because as we saw with the panoramas, there's this huge amount of light pollution coming from the light fixtures. So helping the city and school district kind of plan that to limit the light pollution will help possibly making an observatory at Wilson or just at another suitable location like Gabriel Park. So yeah, that's our project.